So hello everyone. So today we are going to solve the problem bookshop from CSES problem set. Right? It is a standard knapsack problem in which in that problem you have weights and you have weight and profit. But in this case you have price and you have pages. You have to maximize the pages, right? So let's see the problem. You are in a bookshop which says n different books. You know the price and the number of pages. So you have n books and you know the price and pages of each books, right? You have decided that the total price you purchase will at most X. Okay, with this price at most of price X you can purchase. What is the maximum number of pages? You have to maximize the pages. Maximize the number of pages. Number of pages, right? You have to maximize the number of pages. So you have, let's take the example. You have four books. The value of X is 10, right? And you have 4, 8, 5, 3. This is the price of each book. And the pages that you have is 5, 12, 8, 1, right? So what you can do? You can approach greedy, right? Does greedy idea works here? No, right? Why? Let's see. You have at most 10. You can purchase of at most price of 10. So you can see that the maximum number of pages and it has the prices less than 10. So by greedily you can purchase this book. So you purchase it. Now, no, you cannot purchase the any one of the book, right? Any one of the book because if you're going to purchase it, the price is going to be larger, right? So you can purchase only of price 8 with the number of pages 12. But this is not the optimal answer. But this is not the optimal answer. Why? You can also purchase the price of 4 with the pages 5. You can also purchase the price of 5 with the page 8. So the optimal answer is going to be 13 with the price of 9. The optimal answer is going to be 13 with the price of 9. You cannot purchase 8, 12 or 3, 1 because the price is going to be greater than 10, right? So greedy idea is not work here. Is not going to be work here. So what we have to do, we have to try all possible ways. We have to try all possible ways. Try all possible purchase that you can make, right? So initially you have the zero number of pages and the at most price that you can buy is 10. So what choices can you make, right? You have 4, 8, 5, 3 price and you have the books pages 5, 12, 8 and 1, right? So you can take currently we are here, right? So you can take it or not take it. These are the choices that you can make, right? So if you're going to pick, the number of pages is going to be current. These are the pages and this is the price, right? If you are going to take it, the number of pages is going to be 5 and the price is going to be 6. So now you can purchase the book of at most the price of at most 6, right? Now if you are not going to pick, you can have the price is still same, right? The price is still same. Now again you have choices for that. If you are going to pick, if you are not going to pick, right? If you are going to pick, can you pick it? No, because the price is 8, but the Atmos price uh, the Atmos price is 6, right? So you are not going to buy it. You are not going to purchase it. So there is no call on the website, right? So you are not going to pick it. Still remain the same, right? Now, yes, you can buy it. You can buy it. So the number of pages is going to be 12, and the price is reduced to 2, right? Now the second, uh, now the right call will remain the same if you are not going to pick it. Now again, you can have two choices for this, right? You can pick or not pick. Yes, you are definitely going to pick it because the price is 5. 1 second. The price is 5. So, and the Atmos price is 6. So you can buy it. You can buy it. So if you are going to buy it, the number of pages is going to be 13 and price is going to be 1. Atmos price is going to be 1. If you are not going to pick, it still remain the same, right? Now you can call it, and whatever, whichever is maximum among there, you can pick, you can, that will be our answer, right? So this is the optimal answer, that number of pages uh, are 30, right? The maximum number of pages are 30. So this is the optimal answer that we can have, right? So this is how you can try all possible purchases. Now let's try to write our transition
The
states.
transition states.
Transition states. You have two choices, right? That you can pick or you cannot pick. You cannot pick. So uh, let's first define what dpij represents. What dpij represents. So dpij represents up till index I with the atmos price of j. What are the maximum number of pages that you can have? Suppose for dp25, the atmos price is 5. This is the j with the atmos price, right? This is the I, right? We have the atmos price of, we have the value of x equals to 10. So this is the atmos price up till 0 to 10, and this is the indexes, right? We have the extra dimension. Uh, we have the extra dimension. We will talk about it later. Now, dp of ij represents up till index I for dp25, up till index 2 with the atmos price of 5. How many, how much, what are the maximum number of pages that you can have, right? This dpij represents. So to write the transition, we have two methods. The first one is prefix, and the second one is suffix. I I write the transition states by using prefix, right? You can also use suffix, right? For prefix, you have to look at the previous index. For suffix, you have to look at the next index, right? Right. So I uh, I write the transition with the help of suffix by using suffix. Okay. So what you can do is you look at the prefix by using prefix. You are looking at the prefix, right? And if you are going to pick, your atmos price is reduced to p, reduced by p. P is the price, right? If you are going to pick, and you have to add the number of pages, and you have to add the number of pages. Okay. Now, if you are not going to pick you are look at the prefix, and the number of pages will remain same, and the price would remain same. That is j. This is the number of pages that if you are not going to pick, right? Fine, perfect. Now let's try to fill our DP table with the help of these transitions. Okay. So for index one, we have to start index one, right? So for index one, we have to look at the prefix that is 0. So for this, the number of pages, the price is 4, and the number of pages are 5, right? Now, one thing you have to note that when you can pick when the atmos price is greater than equal to the price, right? When the atmos price is greater than equal to the price. So the price is 4. Up till 3, you cannot pick. Up till 3, you cannot pick. So for up till 3, the pick value is going to be 0. And the not pick values, you have to look to the previous, right? So this value is also 0. These values are also 0. So the not pick value is 0 up till 3. You have to take the maximum. So the maximum is 0. So you have to fill with 0, right? Now for 4, you can pick. Now if you are going to pick, next you are going to look for the atmos price of 0, right? If you are going to pick. Now this value is 0. So dp of 0, 0 is 0. If you are going to pick, you have to add the number of pages. So the number of pages is 5. So the answer is 0 plus 5 is 5. So for this, the pick value is 5. And not pick value is 0. That is dp of I minus 1 j. J is 4. And dp of I minus 1 is 0. So 0, 4 is 0. So the not pick value is 0. What is the maximum? The maximum is 5. So you filled it with 5. Similarly for 5, 5 minus 4 is 1. You are looking at the 1. 0. 0 plus 5 is 5. So pick value is 5. Not pick value is 0. Maximum is 5. So for all of these, the value is going to be 5. Right? This is how you can fill for the index 1. Now let's fill for the index 2. For index 2, you have to look at the index 1. For this, the price is 8, and the pages are 12. Right? Now up till 8, up till 7, you cannot pick. Up till 7, you cannot pick. because the Atmos price is less than the price, right? So up till 7, the pick value is going to be 0, and the not pick value is going to be this previous values, right? So you have to take the maximum. So the maximum is going to be for up till 7, right? It is 0, 0, 0, 0, 5, 5, 5, 5. Now for 8, if you are going to pick, you have to look at the 0. For 0, this value is 0. You have to add the number of pages also, that is 12. So the pick value is going to be 12 for 8. And not pick value is 5. Not pick value is just the previous value. So the maximum is 12. So for this the value is going to be 12. Okay. So this is how you can fill for the index 2. Now let's fill for the index 3. For the index 3. For index 3, you have to look at the index 2. For index 2, the price is 5 and pages are 8. Right? What you can do? You can pick or not pick, right? So for this, if you are going to pick, uh, now one thing, up till 4 you cannot pick. Up till 4 you cannot pick, so pick value is going to be 0 up till 4, right? And for not pick, you have to look at the previous. So you have to fill with the maximum. So you have to fill with the maximum. Let's fill with the maximum. 0, 0, 0, 0, and 0, 5 maximum is 5. Now let's fill for all of this. Now for 5, if you're going to take 5, you left with the Atmos price of 0. Yes, so you have to look at the Atmos price. What are the maximum number of pages? 0. So 0, if you're going to pick, so 0 plus 8. This is the value for pick if you're going to pick, and you have the Atmos price of 5, right? So what's the value is 8, because not pick value is 5 and the pick value is 8 and the maximum is 8. Similarly for this, you have to look at the 6 minus 5, 1, 1. What will be the maximum? 0 plus 8, 8. Pick value is 8, not pick value is 5, maximum is 8. Similarly for this, you have to look at the 7 minus 5, 2. So for 2, the value is 0. 0 plus you have to add the number of pages also because you pick. So 8, 5, maximum is 8. Now for 8, you have to look at the 3. Right? You left with the Atmos price 3. Now for 3, the answer is 0. 0 plus 8 is 8. So 8, 12. Maximum is 12 because if you are not picking, you have the maximum number of pages, right? So the answer is going to be 12. Now this is interesting. For 9, you have to look at the, for 9, if you are going to pick, you left with the Atmos price of 4. And you see that with the Atmos price of 4, you have the 5 number of pages. And if you are going to pick, you have to add it 8 or 8 more. So 13 pages. There are 13 pages now if you are going to pick. And if you are not going to pick, the number of pages is 12. So what you prefer, pick or not pick? Pick. So the maximum value is going to be 13 because you have to take the maximum. Similarly for this, the maximum is 13. This is how you can fill. This is how you can fill for the index 3. Now let's fill for the index 4. Now for the index 4, this is why we take the extra dimension, right? For the index 4, you have to look at the index 3. So for the index 3, the price is 3 and the page is 1, right? So for up till 2, you cannot pick. So you just fill it with 0. That is already filled. Let me change its color, right? Now for 3, you can pick. For 3, you can pick. 3 minus 3 is 0. So you left with the Atmos price of 0. So you look at the 0. There are 0 number of pieces. If you're going to pick, you have to add 1. So for this, the answer is 1 because 1, if you're not going to pick, the number of pieces is 0. So the maximum is 1. You're definitely going to pick. If you're not going to pick, the answer for the 4, the not pick value is 5. If you're going to pick, if you're going to pick, then you left with the price, then you left with the price 3. The price is 3. You left with the price 1. Then you have to look at the price 1. The number of pages is 0. And you picked up. So you have to add the number of pages. That is 1. So 1, 5, answer, maximum answer is 5. So you filled the maximum number, the maximum pages are 5. So you filled because you are not going to pick, right? Because you have already maximum answer by not pick. Now for 8, for 5, you are look at the, you left with the Atmos price of 2. So for 8, you have to look at the 2. 0 plus 1 is 1. So you have to fill with it 8. Okay. Now for this, you have to look at it 6 minus 3, 3. For 3, the answer is 0, 0 plus 1 is 1. Right? So maximum answer is 8. Maximum number is 8. Similarly for this node, if you're not going to pick, uh, then the maximum number page is 8. If you're going to pick, you have to look at the 7 minus 3, 4. You left with a 4. For 4, the answer is 5. 5 plus 1 is 6. Maximum is 8. Similarly for this 12, if you're not going to pick, the answer, the maximum number of pages are 12. 8 minus 3 is 5. 5, then you have to look at the 5. 8 plus 1, 8 plus 1 is 9. Maximum is 12. Similarly for this, maximum is 13. Maximum is 13. Right? For 10, if you're going to pick, then you have to look at the 7. If you left with the 7, so for 7, the pages are 8. And if you picked up, so you have to add one more page, that is 9. So 9 when you picked up. If you're not picked, the value is going to be 13. So 13 comma 9, maximum is 13. So you filled it with 13. So this is how you can fill your TP table by doing these transitions, right? Now, what will be the answer? The TP of n comma x will be the answer, right? So let's see the code. I hope you will get the intuition. One more thing, that how can you fill with suffix? So you initialize it with 0, right? You filled with the help of this, you filled row 3, right? You look at the suffix, right? You look at the suffix, you look at the, for 1, you have to look at the 0, for 0, you have to look at the 1, right? You filled this with the help of this, you filled this with the help of this, you filled this with the help of this. This is how you can fill. Okay. So I hope you've got the intuition. Let's try to code it. So let's try to code it. We have the n number of books and we have the prices x, right? Let's take the input. Let's define the vector of price of size n. Let's define the vector of pages of size n. Perfect. Let's take the input I less than equal to n, I plus plus, c in price I for and I equals to 0, I less than n, y would equal this I less than n, I plus plus, c in pages of I. Yes, this is the input. Now let's define vector of int and pp n plus 1 comma vector of int x plus 1 comma 0, right? Now we have to traverse from I equals to 1, I less than equal to n, I plus plus, and we have to traverse from j equals to 0, j less than equal to x, j plus plus, right? Yes. One thing, we have to take the we have to take the prefix, that is price I minus 1. Then we have to take the pages I minus 1, right? Now next thing, what we have to do, we have to initialize pick and not pick, not pick, which is equals to dp of I minus 1 j, right? For not pick, let's initialize it with 0, and if j is greater than equal to price, then we are definitely going to pick it. Now the pick where pick minus price plus the number of pages if we are going to pick it, right? And finally we have to make the transition dp of I j equals to maximum of pick comma not pick, right? Now you have to print the answer, see out dp of n and x. So this is the answer, right? Let's check it once if there is any type of mistake or not. Yes, it's correct. It's correct. Correct. Perfect. 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 Yes. Yes, it looks perfect. So let's try to run it. Let's try to run it. Yes. So the maximum number of pages are 13. Now let's try to print our TP table. For int I equals to 0, I less than n, less than equal to n, I plus plus. For int j equals to 0, j equals to 0, j less than equal to x, j plus plus, c out db of I, j with the space and print it in the next line. C out and mhm, yes. So let's check it out. Yes. So let's try to print it. Yes, this is our DB table, right? The first row, right? The second row, third, and the fourth. And finally, we return the answer DB of nx, right? Now let's discuss the time complexity. The time complexity would be big O n into x, right? Because the first loop goes from 1 to n and the second goes from 0 to x. What will be the space complexity? N plus 1 cross x plus 1. We are using the 2D vector space of n plus 1 cross x plus 1. So I hope you got this. Thank you.
Until we reach it, all you need to know is that we're holding on. We rise up from the dust and claim our throne.